Hi, welcome back to Math Lab, or Smart Bites. I'm not really sure what I'm going to call it yet, but last time I told you I was going to go over some of the limit of the difference quotient problems. These are probably some of the more tedious problems that you'll encounter in calculus. A lot of it goes back to just algebra and really simplification. But once you get some of the shortcuts of the derivatives, you're gonna like life. Life in calculus will be much easier. So with that said, let's go ahead and hit off at least one of these. They're a bit long, but let's get at least one of these in. And this time I think a rational. Let's do a rational problem, and that way you can see one of the more tedious ones here. Okay, let's look. What if f of x is equal to 2 over x plus h? I'm sorry, x plus 1. And as I showed you earlier, the difference quotient is f of x plus h minus f of x all over h. And in this case, we're going to take the limit as h approaches 0, which is really the slope of a line. So we can call the slope of a line in this case f prime of x. So f prime of x is a limit as h approaches 0 of the difference quotient. And so here this is saying we're in our function, wherever there's an x, we're going to plug in x plus h. So let's go ahead and do that. Looks like a 6. Okay, let's see. We have 2 over, here's our x, we have x right here, so x plus h, plus 1 minus our function, 2 all over x plus 1, all over h. Okay, so here's our problem really. Like I was saying last time, if you have an h in the denominator, well, as h approaches 0, we're going to get something over 0. We're going to get a number over 0, and we don't really know what that is, and we don't want that, because then we can't analyze really the slope of this tangent line if we don't get rid of that h. So hopefully when we simplify, we'll find out what it is. There's a lot of different ways to simplify this, but the best way I know of is just to multiply by the LCD, and in this case the LCD, you've probably already guessed it, is x plus h. I'm sorry, x plus 1, x plus h plus 1. And this is actually just on the top here, okay? So I'm going to do the LCD of the top, x plus 1 times x plus h plus 1. Okay, so if I multiply this LCD times the top here, we've got let's just do the bottom too. We might as well do the bottom, right? Let's do it. So the LCD in this case is going to be, okay, so what do we have here? Well, this actually is going to cancel out on this side, right? So we have 2 h x plus 1 minus, this is going to cancel out here, right? And then so we have minus 2 h 2h, and then let's do it like this, x plus h plus 1, and then the LCD times this is h squared, x plus 1, x plus h plus 1. And what I'm going to do is I'm going to go ahead and multiply this out, the top that is, and hopefully what I can do is get rid of this right here. Okay, so let's find out if that's the case, if I truly can get rid of this. So limit as h approaches 0 of 2hx plus 2h minus 2hx minus 2h squared minus 2h all over okay. So right away I can see, look, I can get rid of these, right? That looks good, that looks good. So let's go ahead and get rid of them. And really, all of my terms have h in them, don't they? But I'm not going to factor out the h just yet, because what I want to do is I want to get rid of all my like terms that I can get rid of first, and then I'll factor out the h. And well, I'll show you what I'm talking about. So these cancel out, these cancel out, and now we just have negative 2h squared, which looks good, because look, I have an h squared right here. Cancel that out, and now I just have negative 2 on the top. So this is going to equal, and I hope the camera's set so that you can see this. We have a negative 2 on top, and then this canceled out, right? Ooh, this is a 1, actually. And then we have x plus 1, x plus h plus 1. Okay? And it says the limit as h approaches 0. Well, what's the limit as h approaches 0? Well, this is going to be a 0, isn't it? That's going to be a 0. So now I can write this is equal to negative 2, the top, all over. If we take out that h, we just have x plus 1, right? But there's two x plus 1s, so x plus 1 squared, which is also equal to, hopefully you can see that. Let me check. Yes, you can. Okay, good. Right? Oh, you can't see that. Let me... Okay, there we go. Which is also equal to f prime of x. Okay, so good. So that's using the definition. Like I said, it's kind of long and tedious to do it that way, but until you learn the shortcuts, it's necessary, and also it helps you to appreciate the shortcuts and all the things that people went through just to find that the shortcuts do indeed equal to the limit as h approaches 0 of the difference quotient, or the slope of the line. So anyhow, what I'm going to do also really quick is I'm going to say, okay, well, what if I wanted to find the slope at a particular point here? Well, hey, this is all I need now, right? I'm going to go ahead and erase everything else really quick. Hopefully you got all that. Okay, I found that f prime of x is equal to negative 2 all over x plus 1 squared. Here's a negative, right? Okay, let me make sure it's set up right. Okay. Okay, now what if I wanted to find a point on the line? Well, all I need is if I have, let's say I have some kind of line on here. Well, if I have an x, an x coordinate here, what I can do is I can just plug in that x coordinate. Let's say x is equal to, I don't know, 2. X is equal to 2. Well, if that's the case, well then f prime of x here, we'll just plug in a 2 for the x. And what do we get? We have negative 2 all over 3 squared, which is 9. So the slope at the point x is negative 2 over 9. So if we were to try to find the slope of a tangent line, we would say y minus y1. This is one way to do it. M times x minus x1, where m is negative 2 over 9. M is negative 2 over 9. And then we have an x coordinate, and all we have to do is plug that x coordinate into this equation, and then we'll have our y coordinate. So hopefully that makes sense to you. I think I'll do another one. So stay tuned, and if you have any requests or anything, just let me know. Put it down in a comment below, or just email me. Okay? Well, thanks a lot. Okay, see you soon.